Hey all, this is Mr. P, and today I want to talk about Newton's second law. So first, the rule, as I think you're already familiar with, is that the net force, and I'm going to say on the system, sometimes we have more than one object, so we want to consider all those together, or the system. So net force is equal to the system mass times the system acceleration. And let's take a second to kind of deconstruct what is this rule actually saying. And so if we look at the first part looking at the net force, on the system, let's sort of play a quick game that's kind of an analogy for explaining what that actually means. Okay, so inside the dotted line, I've drawn some numbers, and so what I want you to do is figure out what is the net number inside of the dotted circle. Please take a second and pause the video and figure that out. Okay, well, if we add them all up, the net or the sum or the total, we've got 8 and then 12, 13, minus 3 is plus 10. And one thing to note is that the actual number plus 10 does not appear inside the dotted line. So it's only something that exists in our head or on a piece of paper. It's not an actual real individual number. In the same way, net force is the sum of all the other forces. So it isn't a force that appears on a free body diagram. I guess you could say that if there was only one force, then that force would be the net force. The same way, if I drew a circle and I said, what's the net number inside of this circle? Well, the net number or the sum of the numbers is 1. But there's a difference between adding up all the numbers and the actual numbers themselves. And net force is the sum of all of them added up. And then the system mass would just be the mass of your whole system, and all of that should have the same acceleration. So all the mass in the system should have one acceleration, which is the system acceleration. So let's try to come up with a quick example here and see if we can figure this out. Okay, let's go ahead and think about try to apply this to an actual situation. So let's say we have two boxes. The first one, let's say, is kind of like stapled on top of the lower one, so they move together. And the top one will be 5 kilograms. Let's make the bottom 15 kilograms. And they're both pulled with a rope. Let's suppose we know the tension force to be 100 newtons. And let's say there's some kind of a friction force, which let's say 20 newtons. Sounds good to me to keep the number simple. What's the first thing that you should do to try to understand or solve this question? Please take a second and think about it. Okay, well, the first thing you should do is choose a system. But then the question is, what system do you choose? Well, the best system, the easiest system here, if you can do all the objects together, that's usually a good choice. And here we can, because we're just trying to find the acceleration of the whole system. So both objects together, that makes a good system. Another thing you should do is choose a positive direction. You could choose either way. I'm going to go ahead and choose right as positive. That's kind of standard. The next thing you should draw is a free body diagram. So take a second, pause the video, draw your free body diagram for the whole system. Okay, well, for the whole system, we obviously have some kind of Ft on our system by the rope. And there's a normal force from the floor. Friction force, which we said is smaller. Remember, it's important to show the relative sizes of forces. That's important. And of course, we have a gravitational force. And since the object is not accelerating in the vertical direction or the system, then we know that those forces should be balanced. So we have a free body diagram. The next thing we should do is draw or write a summation equation. So please take a second and write your summation equation. Okay, so a summation equation is basically an expression of Newton's second law. So we just say, okay, the sum of the forces in a certain direction. In this case, I'm interested in the horizontal direction, so I'll do them in the sum of the forces horizontally. And then you say, well, what forces are there horizontally? Well, there's a friction plus a tension, and that's it horizontally. And I've added up all of them. There are no other forces besides these two horizontally. And then that's always equal to ma. And then we just need to start putting in numbers and figuring out. So please take a second, figure out what is the net force acting on this box. Well, the net force is going to be the sum. If we start putting in actual numbers for friction and tension, the friction is going to be minus 20 newtons because it's going to the left. And then the tension will be 100 positive because it's right. And so that means our net force has got to be positive 80 newtons, which is equal to m times a. And now that we have that, please pause the video again and figure out what is our actual acceleration for this whole system. And I guess partly another question you should consider is, what is our system mass? Okay, well, the system mass is everything that's accelerating or everything inside of our system. We have 5 kilograms and we have 15 kilograms. So the system mass is the whole thing, everything part of the system, which means we have 20 kilograms as our system mass. And our net force on that system is 80 newtons times the acceleration. That means our acceleration has got to be 4 meters per second squared to the right. And it seems pretty reasonable. The tension force here is a lot bigger than the friction force, so it makes sense that's going to accelerate in that direction because it's unbalanced force. And the number 4 meters per second squared seems fairly reasonable. So again, key ideas for Newton's second law is to first figure out what is your system net force. Well, even before that, you got to define the system, figure out what the net force is, what the system mass is, and then use this rule to actually figure out what is the acceleration if that's what you're doing. So thanks for watching, and see you next time.